Welcome everybody to our next talk, Nabovarme, open source heating infrastructure in Christiania. So I would like to know, who of you has already been to Christiania, that little free state in Copenhagen? That looks like maybe 60% or something like that. Now, I have good or bad news for you, depending on how you see it. If you mainly associate Christiania with weed, there will be no mention of weed in this talk whatsoever after my introduction, so tone down your expectations. But we will have a very interesting talk about neighborhood heating. That's what Nabovarme means. I just learned it today. So I would like to introduce our speakers, but they will introduce themselves in a moment too. We have Emmerich, Johannes, and Stoffer, and I would like you to give them a warm round of applause.
Thank you. Okay, thank you very much for coming here today and listening to us. I'm Emmerich.
I'm Christopher.
I'm Johannes.
And I will do the talking. I was elected to do the talking by these good guys. And Stoffer and Johannes will answer questions afterwards. And I ask, please ask a lot of questions, because I think we have a little extra spare time. Thank you. So, what is Nabovarme? It's actually it's a distributed central heating system organization thing, and Nabovarme is a word for community heating. We have several heating systems developed by the 14 local areas in Christiania, and the basic of Christiania heating has been pellets for the last 5 or 10 years. Pellets is these small things that you saw in the beginning, that you had in the hands. Let's go back to this. See the pellets, wooden pellets that you burn. And we have a lot of common pellet heating systems inside Christiania. Those are the red dots, the large red dots. And the small orange dots is local heaters in just one family. And we have lots more small orange systems that you have seen here, but we didn't have time to put them in. The history of heaters. We tried to find some good pictures of the original Christiania oil barrel stove, but we couldn't. It's difficult. They're all gone. They burned through back in the 70s, and so all we have are these, on the left, a very common old stove from the 80s. Then we have, of course, the oil heating system, number 2 from left, which was common in the 90s and still is common somewhere in Christiania. Then we have the Becassin oven, which is a popular oven in Denmark for wood, for logs. And you see to the right a typical Christiania installation, which is just a tube going through the side of the building and burning pellets inside and smoke outside. Not very modern, not very efficient, and coming to its end. What we have done is we have taken some very old meters. When we install those meters, when we install some surveillance and monitoring on the pellet systems that we have. Now we're in the phase of combining the users that had these old oil heaters, the wood stoves, the small pellet heaters, into larger systems and that perform better. And a central role for improvement is logging the heat usage and finding ways of making everyone pay the necessary amount and pay it in time. So the logging system consists of these multical 602 So that was first, they were very old when we found them secondhand. And well, then we have improved them with a switch modes power supply to the right in the right picture, and when a Wi-Fi gadget in connection, so making it into a smart meter. The billing and the heating on-off is done through our custom-made database. So remote logging makes maintenance much easier and can over time improve the efficiency of the heating system. That can help the users being more interested in taking part of the heating consumption problems, which is one of our time's main global warming issues, you know. Well, our Nabovarme organizations are organized into the communities. And in our most modern system, every user is using our newly developed prepaid consumption. You know, before, people would go down and buy some logs of wood, and then would go home and burn them. When the burning ended, they were cold. They felt the cool, and they went back, buy more logs, and heating it again. So first you buy, then you have the heat. The same model goes into our prepaid consumption. First you pay for the heat, and then you consume, and then when your use is over, the valve turns off. That is a very simple model, and it means that there is no deficit nowhere. That makes organizing the receiving money in advance for heat and inserting the equivalent amount of energy into the system database. When the user has consumed what is paid for, the module automatically turns off the valve to the user. The thing is that Christiania was founded as on top of an old military base, which was actually coming back to 1680s when the city of Copenhagen was defending itself against the Swedes, the German, and the English. That database was left in the 1960s and was just empty as you see it on this old photo. In 2011, the government of Denmark won a lawsuit against Christiania. That means that the free town was forced to follow the regulations of Denmark. At the same time, Christiania was declared legal, and that resulted in that the local people in Christiania wanted to improve their house standards much more than was used to before. So they put in investments in our infrastructure and in our houses on a longer time horizon. Now we invest up to 30 years in advance, and that's a whole difference than before, when it was just for 1 or 2 years people would clamp up something. So the whole infrastructure is changing in these years. Christiania is quite large. It's 46 years old, and it has almost 1,000 inhabitants. Actually, the 900 that you see here are the inhabitants that we know of, but there are many people that just live there without having a place to stay. That means that they change rooms, they sleep on sofas, they kind of roam around within the community. So there may well be 1,000, I don't know. There are at least 265 houses and 24 hectares of land. There's a heating construction is very easy, kind of. You burn pellets, that's it. But when you extend this to larger systems, it can be quite complex. The pellet burners are difficult to keep in steady production, but they're cheap and can be handled by the local users. Special effort has been done to ensure that the heating system keeps running smoothly all the time by constantly significantly improving the heaters and the steering units. That's the left picture. You see there are some yellow add-ons on top and bottom, and those are added onto an existing heating system that we have bought. We have added air pressure to ensure that the ashes are blown away from the heater's surface at regular intervals. And that you can see on the left picture on the blue tubes. And we're planning to add scrubbers to clean the flue gas. That means you have, when the smoke comes out the chimney, you have a problem with pollution, and we want to take the pollution out of the gas. And this is yet to come, but we're in the process of doing that as well. We're now engaged in improving the logging by the use of the Kamstrup meters you see in the center top picture, and use Raspberry Pis as well to monitor the steering units. That's the bottom picture. That's coming out of a Raspberry Pi. We are fortunate to have several LANs running inside Christiania, and those we can use for propagating the samples and monitor them. That's the right picture here. So you see all these green points are actually Wi-Fi spots. A typical Nabovarme installation consists of a heating production center, some heating consumers, some Wi-Fi infrastructure, and a web portal used for plotting consumption and accounting. Well, back when we started off, the Kamstrup solution meters, they were not very smart. They could actually could take care of the metering of consumers, but we in the city lacked the ability to gather these samples for later accounting. So the Kamstrup company had some solutions for smart metering, which supports multiple protocols. We have the wireless MBUS, the Zigbee, and many more protocols, but there was no Wi-Fi. That meant to us that investing in a new infrastructure for just metering was very costly and unnecessary. All their solutions required a new infrastructure for propagation and data gathering, and a need for certified electricians to install it. The Kamstrup solutions also required a subscription plan in order to gain access to our own data, and we did not like that. So nowadays, many people in Christiania have their own Wi-Fi hotspots. Christiania users are willing to open theirs to the heating meters, and that is a way to reduce the costs of having to manually read the meter, and it's a way to get through the Wi-Fi up to our servers. When researching the existing open source options from the Kamstrup to create a meter logger, we ran across the ESP8266. That's a microcontroller, and when it first came out, it was small and cost-effective enough to be inserted into the meters, and it had the Wi-Fi capabilities to transmit the samples over the existing infrastructure. That means all the Wi-Fis that you saw, the green points. Later, thanks to Martin Gur's ESP library, we were able to extend the coverage to places that lacked their own hotspots. That means that we could hop in, our meter solution could be like an extra hotspot and transmit all the data through some of the heaters to the next hotspot and onto the servers. We created a daughter board to be inserted in the Kamstrup meters, consisting of the ESP8266 with its flash and Wi-Fi capabilities, some triacs for controlling the external valve, the valve that can turn off and on for the consumers, and a separate power supply unit to power everything. And this picture that you see here is put into the living space of the people that are attached to the Nabovarme system. So everyone has one like this. We had a problem because Kamstrup had an open source protocol, KMP, but it was very difficult to read it and to read about it. It didn't kind of work out. And we had to spend a few months to reverse engineer a range of their devices, and they are now supported in our meter logger firmware. And the meter logger firmware takes care of the NAT translations for extending the Wi-Fi, and through a grace period during boot, you're able to set up a target access point to connect to. So that means that when you first set it up, you find the Wi-Fi spots around, and you find the best one, and you lock it into that one. If you later need to change that, you pass along with your own telephone with special code, and then you can change that point again. That's a grace period. That's just a minute or two, and that's it. So after that grace period, it goes over to sample mode, and the scheduler asks the meter for a sample every minute. And the KMP, the Kamstrup, the KMP request talks to the meter over serial, and the KMP receives the data and does checksum before offloading it to the MQTT. And the MQTT dispatcher takes care of transmitting the sample to the server. And another part of the firmware closes the hot water valve if the last sample results in excessive consumption based on the readings from the user's accounts. So this is how we can actually turn off the user, or actually the thing does it automatically. If there's no more money on the account, it automatically switches off. Like when you go down and buy the log and put it into your existing old heater, it burns down, it's cold. Same system. And that transparency makes it easy for people to understand. Some of the, well, that's it. Well, from the client side, you have the overview of a client. This is what the client sees of the production and the use of Nabovarme. We have the propagation temperature, and you have the return temperature, you have the temperature difference, and you have the flow, and you have consumption. And these 5 graphs, you can zoom in and just have it at 1 or 2 minutes, or you can have it for a period like you have from here 1st of January to the 5th of March, but you can also have it for 2 years, 3 years, or just 1 minute, 2 minutes. So this is very easy for people to see how is their usage, when and how much do they actually spend. Now the accounting system, that's one of the headaches for everybody. How to get the money in. We want to supply, we want to share, but we need some money for the pellets. How do you do it? And first, of course, you would just put it on a document on your computer. My neighbor has given me 5 crowns, or as we use in Denmark, or 10 euros. This for the heating of the pellet from that day to that day. Okay. And when you have a lot of documents, it makes it very difficult, of course. So you start with using Excel spreadsheets, or open docs, or spreadsheets, or whatever, And in due time, you find out that's complex too. It makes it difficult. So then some good guys start making custom-made applications, and this is one of them. This is actually the latest application called CA, means Christiania. Forbrug means expenditure. So we have developed that over time, and this is for electricity. This is the red one you see, and that means that it's electricity expenditure. And there is every year one, usually the consumer, but also maybe the area cashier, goes from house to house, takes the number and puts it into this counting system. So you see there, some of them are from 2006, some are from 2005, one is from 15, and two is from 2017. And this is the expenditure of electricity. And we want, of course, to do that also for heating, for heat. And this is maybe possible, but we need some more people to help us doing that. So all this require, of course, individual consumption, total consumption, and production expenses to make this all work. And that is increasingly difficult to handle. And on top of that, users are more demanding. They want to know, how much do I have in our little bank, or how much do I owe the little bank, or how can we actually balance things up? And these data are, of course, very precious to us, and we do not want to share them with large companies for anti-surveillance reasons. And this is why we built up this whole infrastructure, to keep the knowledge inside and to gain total access of it. But it's a lot of work, I'll tell you. So the last thing is that we need your help. We would love to get some more help on how to improve things in our systems, and how to cooperate with making the systems talk together. And we have on the left side of the stage, we have Stoffer here. He's our bus factor, you know. If somebody from bus runs him down, the knowledge is gone. What can we do? We need some more people knowing what is going on. Our society is so small that we do not know what to do. If one person disappears, a lot of knowledge disappears with him. So this is a serious problem for us. And then along as well is the demand for the people that we are serving. They want to know more and more specific details on the consumption, the production, the energy, the economy. It's very difficult. On top of all these things, we have installed a lot of solar panels inside Christiania to stop using so much of electricity that we buy, and getting down on buying the pellets. So all these different consumption models, they coincide, and they need to be balanced out, and we need to monitor them to see how much do we actually gain, how much do we lose. So please, if you have problems or you have questions, we have the problems. And you can apply if you want to come work with us at the Christiania Researcher in Residence. That is a house that we have in Christiania, designed for people that want to know about Christiania, are going to read or do something, some active sessions in Christiania. They can come and stay with us for a month, or come back even, and get some interaction with Christiania. So thank you for your time, and I hope you have a lot of questions that we will be glad to answer. Thank you.
Thank you very much for the presentation, Emmerich. So as you have heard, we have around 5 minutes for questions, and you have heard they are in dire need of ideas, inspiration, support, and help. So line up at the microphones if you have questions. I will start with the internet, if there is a question from the internet. Is that the case?
No questions yet.
Alrighty, then we start with microphone number 6.
Have you given any thought?
Please, yeah, perfect.
Have you given any thought? Great talk, by the way. Thank you. Is there any thoughts for the distribution of pellets to be more efficient within, not just like the heating, and how does the actual physical distribution of the pellets work? Is there any automation ideas around that?
Right. You got it? We don't have any sound right now, do we?
I think we lack some sound on Stoffer and on Johannes. Here's Stoffer. Could you say hello, hello, hello?
Yes, I'll try to. Hello.
Yeah, I think it's on now.
It's on. It's just need louder.
Yes.
Yeah. So right now we have.
Could you have the question again?
Yes. The question was if we are using any automation for the pellet systems and the distribution of them. Right now we have huge silos at each distribution center, so we kind of just get a truck that comes in, then with pressured air it just blows all the pellets into these giant silos. Usually at these production centers we then have redundant heating production units, so if one of them goes down we can switch to the other one. But when it comes to distribution of costs, then it is still small isolated communities that consume their own pellet system, so the budget of one small community doesn't go into the budget of another community. I hope that was answering the question.
All right, microphone number 1, please.
Hi, thanks for your talk from me as well. I was wondering if, like, usually you say first you do isolation on the buildings and then you renew the heating systems. Did you do that? Because like from the photos, it seems like there's a lot of old buildings and stuff, so that would be my first idea, to lower the energy consumption and then put a new system on.
Thank you. Your questions looks like this in here. First, you should insulate your buildings, and then you could add the heating system instead of the other way around. Is that your question?
Well, I was just wondering if you just said, okay, we're putting new heating systems,
yes,
or we first try to lower the consumption and then look for a new system that comes.
The thing is that once you're poor, first you want to heat to survive, and then when you survive, you suddenly find out there are ways that are smarter than the ones you thought of before. So you find a house. You stay there and you heat it. You don't find a house, insulate it, and start heating. No, it's the other way around. And this tends to extend into many decades, so that we have a number of very, very old houses. And some of them are heritage restricted, and some of them are just in very bad shape. And many squatters have been living there before us, and they have not contributed to the betterment of the houses. Right now, as in a new situation, as we are looking into eternity, I mean, we're staying here. We're not being forced out by the police or anybody. So we think longer terms, and we say maybe people live for 5 years here, but they should contribute to the roof that lasts 30 years, and they should contribute to the insulation that we need to have a better house in all 30 years. And this is a plan that takes time and effort, and also needs to be propagated into the mindset of people in Christiania, and not easy. So first you deliver pellets, you give them heat, you find out how to avoid the pellets, and you give them insulation to avoid the heat. This is the way it has been.
All right, I think now it's...
I think you have an extra question? No, is that next?
Please, maybe you can just find the other people who still have questions. We don't have time for all the questions, and you can just talk to them.
Sorry.
Now I think it's the internet's turn to ask a question, because they cannot find you afterwards.
Okay.
Yes, the internet has some questions. First question is, would it be possible to have some holiday in Christiania and help you with your project?
Yes. It would be possible, very possible. So please come join us. You can apply through this web address up here, CRIR, and you can stay there up to 1 month free of charge, of course, while contributing. And we have a very low level of documentation, so a lot of human communication is needed. So you're very much welcome. Come and join us and help us reduce the bus factor. He is taking the bus every day. We are just waiting for him to die. So come and join us and help us.
And I think on that note of the extension of a very kind invitation to all of you to come and join them and work with them, we have to close the talk. I saw you all people at microphones 1, 2, and 8, but unfortunately we don't have any more time. But just come and find the speakers after the talk and discuss with them all the open questions you still have. So please give another warm round of applause to Johannes and Stoffert and Emmerich.
Thank you.